So these are the graphs, and it's, if you could see it, understand that the y-intercept is always the first point to plot, so the 3 is right there. And then you use the slope, which in this case was a 1, to tell you how much to go up and down, how much to go left and right. So how is it that one number tells you how much to go up and down, left and right? How do you turn that into something? You put it over 1, right? All these have slopes that you're going to have to divide by 1. And what is the 1 in the denominator telling you to do? Everyone has got to write 1 in it, okay? And then the numerator is telling you up or down, right? Plus means up, minus means down. So, you know, and it should also get, I think if there was one mistake that I was seeing, it was mostly on 30, right? That on 30, that's incorrect. What's wrong with that graph? What did they do? They copied this one over to here. There's your y-intercept is -1, and the slope is up 4 over 1. They copied the same graph. I mean, the very point I was going to try to make was, you know, we understand what's a positive slope and a negative slope. When you see the negative, you know the line's going down. It can't be going up. It's got to be going down. This one should have had a y-intercept of 6. A slope was -1, and these are something like that. That's what it should have looked like. I think the rest of them look okay. You notice they've got a scale of every grid line is every 2. Guys. Okay? And then the other part of it is, if you're given an equation, right, that was one kind of test question you're going to get. Okay? The second is, if you got an equation which is not in slope-intercept form, how can you say what's the slope and the y-intercept? Solve for y, right? Solve for y. When you've got the y isolated on one side, you've distributed, you've no more parentheses or anything, combined like terms, then it's in slope-intercept form. And then you can say what's the slope and the y-intercept. So, for example, in this one here, I would subtract 4 from both sides, which is going to give me y equals -6x plus 4. Right? Why don't I put those together into one term? The -6x plus 4. They're not like terms, right? You can't put those together. All you can really do is just write them, you know, we usually write them like in the order of mx plus b. But you could write 4 minus 6x. That was a -4, wasn't it? You could reverse the order. It's okay. You still should know where it is you're looking for the slope and where is it you look for the y-intercept. The slope is the number only in front of the x, right? That's where they got that. And the y-intercept is the number, the constant term at the end. Right, so you don't want to answer the question until you solve for y. Okay, so that'll be another kind of problem on the test where you've got to solve for y. But another kind of problem on the test is what we did in the very first section. If you're given an equation like this, can you identify the slope and the y-intercept? So there's the third kind of question right there. So you can check. This one was maybe more complicated than the rest to solve for y. And simplify, right? I would have to use distributive property, 1/3 x minus 3, and then add 5. Y equals 1/3 x plus 2. So the y-intercept is 1/3, the slope is 2. Okay. Now today what we learn is about another form of a line which is called point slope. And point slope, what do you think you need to use the point slope form of a line? Just think of the name of the line. You need a point and you need the slope. Okay, if you've got those two, then you can use this equation of a line, which is right here. Y minus y1 equals m times x minus x1. So the x1, y1, what is that? It's a point, right? So you need 1 point, x1, x sub 1, y sub 1, that's a point. And the m, we know what that is. Right? That's y2 minus y1, x2 minus x1. So as long as we know 1 point in the slope, then we can use this equation for a straight line. Right? Now, if you were going to graph it, as long as you know the point, I mean, how is this different than graphing slope-intercept? We graph slope-intercept, what's the first point you graph? The y-intercept, right? Well, here, you may not have the y-intercept, but you've got a point. Just go to that point and then use the slope to find another point on the line. Right? So we can use it to graph, although usually you don't, but that is part of what they're doing here. So a line passes through a point, negative 3, 6, and has a slope of negative 5. What's the equation of a line? Now, you can see this whole section is about point slope so we're using that form of the line, and we're going to plug in for the x1 is the negative 3, y1 is the 6, and the m is negative 5. Now, once you put all that into the equation, you know, what did they do to go from this line to this line? They didn't even do that. They changed a minus and negative to a plus, and that's it. And they actually didn't ask you to put it into slope-intercept form, but you should be prepared to put it in slope-intercept form, kind of like that one homework problem we just did. How would I put that into slope-intercept form? Solve for y. Simplify, solve for y. That's always the answer. How do you put a straight line in slope-intercept form? Solve for y. So in this case, y minus 6 is negative 5x minus 15. Add 6, add 6. Y equals negative 5x minus 9. Right, so that's point slope. Same thing. Given a point and a slope, write the point slope equation of a line. So you've got to know y minus y1 equals m times x minus x1. Right, what are you going to substitute for x1? Nope. Remember, this is the x1, y1. So the 8's going to go there. Y1 will be that. And the slope is 2/3. Right, fill all of those in. Y minus negative 4 equals 2/3 x minus 8. Right, since they said put it into point slope form, you know, you don't have to solve for y because they said to do that, and you won't have to on the homework either. They probably would have taken one step, though, like they did on the last one, right? They probably wouldn't leave y minus negative 4, right? What would they convert that to? Y minus a negative is y plus 4. So you probably at the very least want to do that. Y plus 4 equals 2/3 x minus 8. You know, you should never leave a minus and negative. And I've seen a lot of times that students will leave that, and then maybe you're trying to solve for y, and you get confused over what you're supposed to do to move that negative 4. So it's much better, you know, make it into a plus 4, and then very clearly, what would you do to move the 4? Subtract 4. Right, subtract 4. So you should be able to take a line, a point, and a slope and make the equation a point-slope form of a line. Did we already do that one? Yeah, we already did that one. I don't know why I did that. Now this is Going back to, we made the slope-intercept form of a line in section 5.3, right? And if you remember the steps, these are the slides that we used then. Given 2 points, how did we come up with the equation of a line? The first step was calculate slope, because that's what you can do with 2 points, calculate the slope. And we did that. Remember that? And then how did we needed to find the b. How did we find the b? Which equation did we use to plug into? The slope-intercept form, right? We did this. You start with y equals mx plus b, and you plugged in one of those 2 points and the slope, and you solved for the b. Honestly, most of the time, I mean, I have to do this frequently, okay? And I would use point-slope form. I would not use this. I would definitely calculate the slope first, but once I had the slope, what I would do is I would use 1 point and the slope in point-slope form, like this. Y minus 1 equals negative 3x minus 2. And then solve for y, and it'll be in slope-intercept form. Y minus 1 equals negative 3x plus 6. Add 1, add 1. Y equals negative 3x plus 7. So, this second step of finding an equation for a line when you're given 2 points, you don't have to use that. You could also use point slope. I'm just going to show you that this is where I end up doing this, and I'm doing it to convert an SOL score to like an equivalent class grade. Like, Aquarius, put away. Didn't we just talk about this? Put it away. Obviously I'm interested in math, and I'm a math teacher, so you might think, oh, this is just because he's a math teacher. But any teacher that wanted to see, like, where would your SOL score put you on a grading curve that goes from, 64 to 100, would use the same process to do it. And I do that. I do that for SOL scores. I do it for AP grades, which are on a completely different scale. How do you try to equate one to the other, right? In this case here, and literally I would do this. I'm about to do it for the SOLs coming up. What's the minimum passing score for the SOL? 400. What's the minimum passing score in the class? 64. What is, and I'm using the beginning of pass advanced would be the beginning of an A, right? So 500 is pass advanced on the SOL. 90 is an A in our grading scale. So I'm going to use those 2 points, right? Here we go. 400, 64, and 500, 90. And do what we just did on the last thing. I want to come up with a slope-intercept equation of a line. So the first step would be calculate a slope. M equals y2 minus y1, 90 minus 64. Okay, divided by x2 minus x1, 500 minus 400. So our M is positive 26 equals 26 over 100. And we could simplify that, right? What's 26 over 100 simplified? What's the common factor? 2. I mean, they're both even. 13 over 50. Okay, now that I know the slope, I can use point slope form, use one of these 2 points, it doesn't matter which one, and that's slope. Y minus, I'm going to use that one, 64 equals 13 over 50 times x minus 400. And at the very least, I'm going to add the 64, right? That's 13 over 50 times x minus 400 plus 64. Right? That's an equation now I can use If I know what the SOL score is, in between those two, I can make it into a class grade. Right? So, I mean, I find that pretty useful for many different reasons. But I have to say, I never use y equals mx plus b to find the b. I always plug it into that and then solve. Okay, the other thing is, the other part of the homework will be graph a point slope form of a line. So what are the two things we're going to get out of this? It's point and a slope. What is the x1, y1 in this equation? No. Positive 2 and positive 1. Remember that in the equation, it's y minus y1 equals m times x minus x1. So if it says minus 2, that's part of the formula. So x1 equals 2. And what is the slope? 2/3. So graph the point, 2, 1, 1, 2, 1. Use the slope to find another point on the line. Starting at that point, how is this 2/3 directing me to another point on the line? Up to right 3. So from this point, up to right 3, there's our line. So, I mean, it's pretty similar to slope-intercept. Just slope-intercept, you always know one particular point, right? The slope, the y-intercept. Here, it could be different. One more time. What is the point that we're going to graph on this one? Four, -7, okay? And so I can put that 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, right there. Okay, now how am I going to use a slope of -4/5 to find another point on the line? Okay, let's say I go down 4 and right 5. Where would that put me? Down 4, right 5, I'm not even on the graph. How could I do that a little different? Yeah, instead make it +4 over -5. It's still a negative fraction, but now it's telling you to go up 4 and left 5. And that actually keeps you in the graph, which is a choice you could make or not. If you want to, extend your graph down, then you do it. Up 4, 1, 2, 3, 4, and left 5. Well, that's funny. I don't even have that point on the graph. So there's our graph. So our homework is going to be page 151, 1 through 7.